Okay, so one of the questions that I have been asked is what is the difference, the major difference between what the equation of an ellipse looks like and the equation that a hyperbola looks like? So I'm going to work through both of these equations you see on your screen, taking them from general form, which they're given, into standard form, and point out the difference that you should really see to help you identify that what you have is an ellipse or a hyperbola. So that's going to be our goal here. So I'm going to start with the ellipse. I'm going to begin by rewriting this so that the terms with matching variables are grouped together. And then I'm going to move that constant term over to the other side, which is very similar to what we've been doing throughout the course of the chapter. So this would be equal to negative 249 at this point. So now remember that when you are working to complete the square, you have to have your quadratic term, your x squared or your y squared, have a leading coefficient of 1. So with the x's here, I currently have a leading coefficient of 4. So I need to factor out that 4, which will make this x squared plus 2x. I'm going to leave space for my constant term. And then on the y's, I'm going to need to factor out 49. Now, since that 49 is positive, I'm going to write that as plus 49. And then this would become y squared minus 6y, leaving space. And this is still equal to negative 249. So I've not moved anything from side to side. So here, b over 2 squared, so 2 over 2 squared becomes 1 squared, which is 1. So I'm going to add 1 here, knowing that on the other side, that means that I'm going to be adding 4. So my x's then, I still have that 4 out in front, but this would become x plus 1 quantity squared. Remember that this one is what goes there. And then as I consider my y's, here I would have b over 2, so negative 6 over 2 squared becomes negative 3 squared, which is 9. So I'm going to add 9 there. But then when we add 9, remember that then I have to take that 9 times the 49 that you see. So I have to distribute here. So on the other side, I'm going to be adding 441. So this means that I have still that 49 that I factored out, and then my y's are going to become y minus 3 quantity squared. And then this is all going to be equal to a positive 196. So at this point, you would be able to count out hyperbola as an option. So if you were trying to figure out what this was, we're not completely done with it, but because of this here, you should be able to discredit the idea that this would be a hyperbola, because a hyperbola has a subtraction sign connecting the two variables together, and this has a plus sign. The two things that you have on your reference sheet that look similar to this would be a circle and an ellipse. The reason that I know that this is not a circle is that a circle does not allow for these coefficients in front of the parentheses. So that tells me that this has to be an ellipse. So in order to get it into that form, the standard form of an ellipse has to be set equal to 1. So I need to divide through by 196 all the way across. So when I do that, I end up with a denominator of 49 here on my x's. And then on the y's, I end up with a denominator of 4. So this would be the equation of your ellipse in standard form. Again, I know this is an ellipse because of that addition sign that connects them together. So jumping over to the hyperbola then, because this process is going to look very similar, so it's important that you're I hope you're understanding the process at this point, but more so that you're understanding the difference between this left side and right side of the board you're seeing on your screen. So I'm going to start this one in the same fashion, and I'm going to group together the terms that have x's and the terms that have y's. And I'm going to move that constant term, which in this case is 25, to the other side. So on the x's, in order for me to complete the square, that leading coefficient has to be positive 1. Right now it's 49, so I'm going to factor out a 49, which gives me x squared plus 4x, and I'm going to leave space. And then on the y's, I need the leading coefficient, the coefficient on y squared, again to be positive 1. So that means that what I need to factor out here is a negative 1. So this is going to become y squared plus 10y. And again, it's still equal to 25. So at this point, I'm ready to go through my process of completing the square. So here, I need b over 2 squared, which becomes 2 squared, which is 4. And when I distribute that 49 in, that means that what I'm adding to the other side is 196. So I can say that the x's still have that coefficient of 49, but it would become x plus 2 quantity squared. Now I would have that negative 1 still in front of the y's as I move down to the next step. And then I need to figure out what is my constant term for my y's. So b over 2 squared becomes 5 squared, which is 25. So I'm going to add 25 here. But then when I distribute in that negative 1, that means that on the other side, I'm really going to be subtracting 25. So now the y's become y plus 5 squared, and this would be equal to 196. So at this point, really, you should be able to determine that this is a hyperbola. Now, we're not in that perfect standard form that you see on your reference sheet, but because of this sign right here, we know that this is a hyperbola. The only conic that you have on your sheet that can look like this with a subtraction sign is a hyperbola. So now we just need to make it match standard form, and standard form says that it has to be equal to 1. So I need to divide through by 196. So when I do that, I end up with x plus 2 squared over 4. That subtraction sign that I circled is what's going to connect these two fractions together. Y plus 5 squared over 196 equals 1. Hopefully this helps if you have been struggling to see the difference between those two types of equations. And if you have further questions, make sure you're asking or posting.